Hi, I'm going to talk about the record service, which is authorization level of security. But before that, I'm going to go ahead and talk about the concept of ring of defense, which was talked or used in today in security with Apache Knox in Hadoop Summit 2014, I believe. So, the perimeter level security, it's the most outer layer that stops the bad guys at the network level using network security and firewalls, or the API level, which is Apache Knox or the gateway. Next is the authentication layer. Here's the orange. And if you don't have this layer, then authorization layer doesn't matter, because the whole concept of authentication is to figure out who the user is and validating its role or claim. Kerberos is used in authentication layer, and Kerberos is a compute network protocol that works on the basis of tickets. It allows the nodes communicating over non-secure network to prove their identity to one another in a secure manner. In short, your ticket cached on your system is used to authenticate, allowing single sign-ons or SSOs, and avoiding storing passwords locally or sending them over the internet, which is how it goes over the non-secure network. Next, we have authorization, and here we're gonna just focus on the Hive authorization next generation, I believe. It's something developed by Hortonworks, but we're gonna look at the record service, which is developed by Cloudera. And it's a SQL-like authorization that will include grants and revokes on the table and column levels, but we're going to go that in deep later. The OS security is the process of ensuring OS integrity, confidentiality, and availability. The OS security refers to specific steps to protect OS from threats or some type of intrusions. Most of the examples involve volume-based preventions, or some things that I read are pattern detections, which prevent threats before they can fully hit the system, because most of the malicious code has a similar patterns of intrusion. And lastly, we have the data protection, which is basically the encryption. And this is putting a lot of effort or real ability on the user to protect their data in case all of this, a hacker or a malicious intruder went through all of these layers. You at least should have your data protected by encryption or tokenization or I don't know, fake data. So yes, this is the rings of defense. Next, we're gonna go into this, which is a Strata plus Hadoop conference that happened in 2015, and this is where the concept of record service was introduced. And here is the PowerPoint that we're gonna use, but these are three people who presented. One of them just talked about the general understanding. The second one talked about architecture, and this presenter talked about Capital One being one of the first users to use the record service in a large environment. So let's go. Okay, so here I'm gonna make it not do this. Yes. So in here we have yes, record service. So record service is an Apache licensed open software, and it's a distributed scalable data access service for unified authorization in Hadoop. The key principle of the service is applicable towards more larger enterprise organizations with running Hadoop clusters or Hadoop ecosystems, due to the larger or greater amount of users with different privileges on the data stored in tables, meaning that different users will have different privileges on the tables. So motivation for this was Hadoop is expanding, Hadoop is growing, and for the Hadoop maturity, security, performance, and compatibility are three important requirements that should increase as Hadoop gets better. So these are some of the compute frameworks and storages. Compute frameworks, MapReduce, Pig, Spark, and then storages and file formats for K-Avro. Here we have an example of security. So the challenge was to provide unified fine-grained access security across the compute frameworks. And two challenges with that was integrating security layer into every component is very hard. And then the other point was that file level precludes fine-grained access control over column and row. So it restricts it. File level restricts fine-grained access, meaning that file echoes are good, but they're not enough because you can only grant a file to a user to see it or not to see it. And if you have that, there's a lot of limitations because then a file must be split, and then there's duplicate data. So one file is not enough. There should be couple files, and then that's a huge operational cost because files are large. So the solution was to add a level of abstraction. So secure service to access dataset in record format. So important part of this is that a dataset, which is a file, becomes a record, which is an abstract of a file. So here it's a projection of a dataset. That's what the record is. And then the control policy can be applied to the file and the frameworks. And this is same slide. This is kind of the visual of this. Here's the compute: Spark, MapReduce, Hive, Impala. Impala being similar to Hive, developed by Cloudera for optimization. Record service is that abstract, and here is the storage. Okay, so what does it do? The architecture, it simplifies the data into tables of view, data in tables or views. So now the data becomes table or view. View can be created from a table. Then there's HCatalog, so security, what is it? There's authorization checks using security Sentry metadata, and that's what we're going to talk about, and accelerates the data access path. This is the performance improvement with this Impala. So here's the architecture, something that I wanted to talk about. So the architecture, so a record service compromises two services: the record service planner and the record service worker. The planner is responsible for generating tasks and authorization. Each task describes a work unit. Let's look into these. So the name node is a centerpiece of HDFS system. It keeps the directory tree of all the files in the file system and tracks them across the clusters in the file where the file data is kept. It doesn't store the files themselves because that's not its job. It's the data node job. The Hive Metastore service stores the metadata for Hive tables, or this could be, Impala tables, and the partitions in relational database. Sentry is a, I believe, remote procedure call that stores the authorization metadata in also relational database, and then it provides interfaces to retrieve and manipulate privileges. It supports secure access using Kerberos, so it uses the Kerberos, and it doesn't actually handle the privilege validation by itself. The Hive and Impala services that will use Sentry to validate the authorization. So next we have the record service workers. These execute tasks and return reconstructed files or records. In this sense, it would be records because they went through abstraction. And compute frameworks such as MapReduce, Pig, Spark will launch the map tasks on the worker node. Each worker node talks directly to the data node, which are here the HDFS, HBase, and S3, which is the storage, but there is a data node, to read the data and then perform the computation. Kind of a good way to think about it is a planner is a layer of abstraction over the metadata service, which are these. And then the worker provides a layer of abstraction of data storage, which is the data nodes. Here we have, I guess, the description of this is the planner service. It's responsible for metadata, for creating tasks, and performing authorization. The worker reads from the storage and constructs the records, so it's doing a lot of I/O, file parsing, and then runs the DAG computations. Here's the APIs, we don't want those. Here's fault tolerance, yes. Oh, here's the architecture for the security, which is where we talked about the Kerberos and delegation tokens to use as authentication. And here are a couple of things. Column planner authorizes requests using metadata in Sentry. So it authorizes a column level ACLs, which is a user can only see certain columns on the table or on the record. Then there's row level ACLs, which creates view with a predicate, which means that you would create a view by filters. So you would take a column and then you filter it by I don't know, numbers, by certain numbers, certain amounts, certain names, and then you create a view that way. This is how the row level ACL would work, because you would create a view with, instead of 50 rows, like with less rows because they're filtered. Masking is to create a view with masking function in the select list. That means if you want to mask, the most common example would be SSN. Masking SSN would go ahead, you would go ahead and instead of having SSN would just replace it with dashes or stars. And tasks generated by planners are assigned with the shared key. Yes, that shared key is used to not shared key, but the signed tasks are used for workers to go ahead and run things. Here's an example of how to create a view and how to do the predicate. Next, this is APIs that we here is APIs integration. Here's the text and Avro format, Spark-A format. Here's an example of a MapReduce job, and here we see how it's simple to use record service now in compute framework. So in a MapReduce job, Spark job, or big job, and here we just are setting the input table, and then we're just adding adding this package, our input format, that class. Here's the Spark example, how to easily convert basically this is how to easily convert your compute application to use record service in a environment where otherwise you're not supposed to be reading the files or something. For the performance, so record service talked about performance and how Impala helps the performance, and it's optimized with C++ code. And here they use the Teradata Sword, which is 78 node cluster, and they ran these billion, 50, and 1 trillion scales. And here we see that with MapReduce, there is a huge difference in running 1 trillion, I guess, Teradata checksums. And the reason why, because the record services reuses some of the components of the Impala, which is I/O management. And because it's an existing application, it improves the performance when run with record service. To go into details of that, you would have to read how does Impala work. Then they did Spark SQL, and they got a bunch of performance metrics. So yes, this is about Capital One using record service because they were one of the partners in early development. This is talking about how Capital One had a use case, Cloudera took it, developed something, and now Capital One is happy. And everyone wins. So this was a fast slide on record service, which is available on this Strata Hadoop if you Google record service. Here's the Cloudera's blog that has a good info about this. And here is their main website that has a quick start VM, which we're going to do, and run a couple examples. So we're going to continue on, and the second part of this recording is going to be the demo. And here we talked about the Quick Start VM. Just wanted to mention that you can install the beta and install it on your own CDH cluster, as well as do something as installing record service from a package that is not recommended. And I was trying to install record service on the single node cluster, but it was pretty hard to do, I would say. So I went with using Quick Start VM. And for that, you just need your VirtualBox, which I had, and then you needed to go into this GitHub and clone it, and then it will open up to you would have to open up in the terminal and then run the script install sh. So with the install sh, I actually had a lot of problems. So I instead did something silly in sense of, here it is. So it was not working because my, I guess, VirtualBox was not set up correctly, or the path was not set up correctly, rather. So this is the step that was giving me troubles, and makes sense why. But it would get stuck on this step and just halt. So I commented out because the thing that I needed is basically SCP and download that OVA image, so I can load it into a VirtualBox. And so that's done. That was done, and I got my .ova image here. So the next step, to open up your, I guess, VirtualBox, and if you get stuck on, the next step that I was stuck on is obviously the VM, vbox start VM, because it couldn't find the vbox manage in the beginning, so it couldn't really open it up. So I just decided to open it up myself since I have that OVA image. And the way to do it is you go into File and then you do Import Appliance. You choose your OVF or V8 or OVF file. Mine is gonna be here, and it is, one second, OVF. I kept saying OVA. Open visualization format, OVF. Then you go next, then we see it's a Red Hat 64-bit. You can specify the RAM. I think I specified 8 gigs of RAM because I have 16 gigs of RAM, so I didn't really care about, I wanted to process a couple of things faster. So make sure to get 75% top of your RAM, or maybe half. And then you do import, and I'm not going to do it because I have it right here, and this is my Cloudera quick start. So we're going to start a machine. It's going to take a while, but we are going to pause until it starts, or until it loads it. Or we're going to just wait for a little bit. But if it loads slowly, then we'll stop. So we started our VM, and this is how it looks like. So we're gonna go ahead and start by going into etc folder and then checking out what's there. And we see a lot, the concept of groups here put in. We see, but we're looking for record service, and it's here. So let's go explore it. Let's go into config file, There's no config file. Okay. We can go into Sentry. That's where the permission part is. So Sentry, we're gonna go to config. There is site XML, so we're gonna open that up. So here we see, I guess, the use of the relational database, the Derby database. And then we see the RPC, which is the remote procedural call that Sentry uses to communicate. That's cool. Well, we're just gonna go ahead and go into, I think, the Impala itself. I don't think I copied that. Nope. So Impala. So here we are. We're gonna start with show databases. And show databases has all these databases we're gonna be using for this, the RS database. And then show tables, and then we're gonna select all from employees table. As I'm writing, obviously select all from employees employees. Okay, here we go. There's 50 records here. There's first name, last name, position, department, salary, and phone number. So we're gonna, I guess, test out the concept of roles and granting the role on a column-based filtration. So here we will look at the show roles. We have one role, DB creator, which is probably something that I have because right now I'm able to create databases. So we will create role, let's say, demo user. Here we create the role, and then we need to grant that role to a group, just because usually what happens is there are a lot of users in enterprise companies, and then every user has a group, or a user ID is put in a group. This way you have to put less permissions on the group, or you can manage the groups better. So that's what we're exactly gonna do. We're gonna grant the role demo user to group demo user. Actually, we're gonna run demo user demo role. Okay, too late. Demo user role. Too late. Okay, we'll just grant. It's supposed to have a create a role demo user underscore role, but you can go ahead and do the same thing. But you want to differentiate the role from the user, but I already made a mistake. But since it's just a relational database, it's gonna check you're able to just even create but by specification you should be putting role in the back. So to group, so we granted show roles. Okay, that's good. Demo user. So now what we're gonna do, we're gonna grant a select, and we're gonna grant a select first name, last name, and phone number. Phone number on a table rs.employees to role demo user. boom, boom. So here we're granting the query. Yes, it looks like it's done, so we are gonna exit Impala. And now we're gonna go ahead and run this, which is a MapReduce job. It's a record count, and here I can show you how it looks like. It's basically a record count map that takes in input of a table and then just counts each row and then tells you the rows. Tells you how outputs the number of rows. Where is it? Here. Here's the sum. And to replace it, to use record services in this, what we will do is we will just replace, instead of the job set input, we're going to replace with record service config. Also, actually, to make this even better, no, we're going to quit. We're going to run the job first. So here's the job. And here what we're going to try to do is we're going to try to select the last name and salary from the table, which should not work because, okay, no valid jar because we're not in a home directory. Now we're in a home directory. Now we should run it. So it's going to select last name and salary from the table and try to output it in this HTFS location. But it's supposed to fail, which it does, because demo user does not have privilege select on RS employee. So this is a little bit confusing because it does have a select privilege, but it doesn't have the select privilege on the tables that we have listed, on the columns that we have listed. So here we're going to go ahead and do the same exact thing, but we're going to say you go ahead and run to select first name, last name, and phone number. Phone number together seems like a weird combination. And here I wanted to just quickly mention that here the arrow, here we got the privilege exception at the record service planner area because this is the area or this is the service that goes through authorization area layer, and if there is no granted authorization, then it halts, so it doesn't go to the worker. So here is the second job, and we see something goes on and goes on and goes on and goes on, and the job is submitted, and it looks like it's mapping and reducing, so we are waiting on that. Yes. Perfect. So it did look like it wrote into HTFS location, and I have it saved right here. So we're just gonna go ahead and cat it. And I just had a cat jump off my table, so cat it. So here's the 50 records. So we get all 50 records because the whole point, the program was trying to count how many records there are. And we saw that we have 50 records. Perfect. So I'm sorry, I had a cat emergency, but let's continue on. So let's now test the row level security. And row level security, we would need to log in as Impala, because that's the admin here, and we're gonna go ahead and create a view. So as you remember, row level security goes by putting a predicate on a table and creating the view. So we're going to go ahead and do that. So we're going to create a view called, we're using this database RS and call it without police. And then we will select all from as.employees where position is not police officer. create view. Okay. Where? Wait. Create view. Wait. Create view without as, because we're giving it as select, and we're not getting positions. So it's supposed to be where position. So it looks like now it's successful. Perfect. So now we will grant select on the table, on this table, which is a view actually, to the role that we have. So it's grant select on table rs dot without police to role, and we had demo user. Boop. Done. So we're granting the select on the table right now to the demo user. So this user would be able to use that table or use that view and see everything, count the rows or run the MapReduce on that view. So now let's quit. Actually, before that, let's do this. So let's grant select on database. I'm hoping I'm doing this right. Grant select all on database. All on database to role user demo. Did I say demo user or user demo? Demo user. Okay. Yep, I knew that might not be it. Nope. Okay, let's let me fast look up something. Grant database to role Sentry. Oops, I accidentally put that. So what I'm trying to do is I'm trying to later on log in into Impala as the user and then check that these are the only things that I can see. So grant select on table, on table, on table. I want to, there's no on database. So here's I guess good things to look at. Grant all on database name to role. Okay, let's try that. Grant all on database rs to role demo user. Yay! Okay, so we're gonna test that after we test the role level security. But anyways, we will quit now, and we are gonna go ahead and look at this, which is we're running as a demo user. We're running the record count, and we are using no police. We're using to remember without police. Let's use correct row. Correct view table. So okay, that looks good. Output 1. Let's just do that in case. And now we're gonna run this. Let's see what happens. So this is ideally is running as a demo user. It's supposed to access the planner, and we see how here it passed the record service planner, so it passed the authorization level. Now the tokens for the job are submitted. We can open this up. I've never tried to open this up, but we can open this up, and this is supposed to just use Hadoop job history server, but it's running very slow, so I don't know about it. But the mapper is running. We're gonna see if it returns us the 38 rows that it's supposed to return after it maps and reduces. Oh, here we go. We see the map reduce application. It's running. Total mappers is 1, running 1. Map is complete. Reduce is in stage. Oh, and now it's complete. So now we're gonna go ahead and go into the directory and cat the result. Dun, dun, dun. And we see the 38 records. So the user was able to do that. So now what I wanted to do is I wanted to we're gonna log in as Impala shell as the user demo user. So now we have less privileges, supposed to have less privileges because we're not Impala. So let's do show databases. Yes, do you see how before we had all the databases, now we granted the RS database to the user. Now we can do use RS. Show tables. But one thing about the permissions, so I'm assuming that, let's just do this before I put in my assumptions. Yes, okay. So before we granted the demo user the view only on users on select columns. But now because we granted all on database, it's cascading permissions. So we're getting the database, all the tables visible, and we're supposed to, I believe we're supposed to be able to select all from users. Let's see if that's the case. Or if it gives us arrow. Nope, that's we didn't want users, I mean employees. So yes, it gave us all 50 records just because we don't our permission now is trickled out to database, to all the tables and all the columns. So now we have full privilege. But before we could only see anything within the scope of this, and phone number fields. But yes, so this is a quick little tutorial talking about now that enterprises are growing and Hadoop is growing, it is important to have some type of security, and this is a very interesting authorization layer security that gives the companies or the use cases as having a lot of employees and only certain employees are able to see some type of columns or have a row-based filtering available to these companies or use cases or enterprises. And this is it for the everything. We have the database, everything is done, so I don't know, thank you. Yes, Cloudera doesn't really make it easy to get record service installed on single Hadoop cluster that I had previously installed, but I mean at least they have VM and it was nice, and plus you can play around with more projects because they have tons of things in the etc folder. Thank you, have a good everything.